Hi students, so now we will be solving this particular problem. After having solved a bit of a beginner level difficult problem, you could say, now we will just try to proceed forward with this question, which is nothing but integration of 1 by sine x cos cube x dx. Okay, so here we have to do a small thing that will help us solve this problem entirely. That is, you have to divide both the numerator and denominator by, you have to divide, okay, divide both numerator and denominator by cos to the power 4x. Now you might ask, how will that essentially help us? You will get to know about it very soon. Whatever manipulations we do, it is just to ensure that we can make our problem more simplified so that we can get a quick solution to our problem. Now as you can see, there will be a dx here. So as you can see, I have divided both the numerator and the denominator by a cos to the power 4x. Now our work is to actually get down to the point. We know that 1 by cos to the power 4x is nothing but sec to the power 4x divided by this cos 4x and cos 3x, right? So the cos 3x part will get cancelled from here, so we will be left with a cos x in the denominator, right? What I'm trying to say is, you have this, right? So I can write this cos 4x as cos cube x into cos 1x. This only gives us cos 4x. So this gets cancelled. So I'm left with sin x divided by cos x, which is nothing but tan x into dx. Now I hope you can understand what next we will be doing. Alright, simply we will be breaking this into sec square x into sec square x divided by tan x into dx, right? And then what next? What is sec square x? Nothing but 1 plus tan square x into sec square x divided by tan x. I hope you are getting, I'm just running forward because these are all the things that we have done before, okay? So this doesn't require a lot of explanation. The power and exponent logic I have explained a number of times. This is why I didn't explain it anymore here, okay? I have already told you that 4 can be broken into 2 and 2, because ultimately we have to add the two powers and we will get a 4 only. Why I have done this? So that I can get a 1 plus tan square x. This will simplify our calculation in many ways. How? Because if I take, say, if I take tan x as a t, then sec square x dx will become a dt, right? So what will I be left with? I'll simply replace this, right? I'll get a 1 plus t square. Sec square x dx is nothing but dt, as I have written here, divided by tan x, which is nothing but t. Now, as I told you, you will simply 1 by t this will become, and this becomes t square by t, which is nothing but t into dt, right? And now you can solve it, because integration of 1 by t dt is nothing but log of t, log of mod t, plus this part t is nothing but t square by 2 plus c. The only work that you have left is to actually replace these t's by tan x, by the original function that we have considered here, okay? Now this is our next problem, okay? This is a very easy problem, but again a bit of manipulation. Here in the denominator you can see that we have 1 plus sine 2x, right? Now we know that we can write sine 2x as 2 sine x cos x. Can we write or not? We can write it, alright? So if sine 2x is 2 sine x cos x, then, and one more relation if you remember, we know that cos square x plus sin square x is nothing but 1, or sin square x plus cos square x equal to 1. Trigonometric identities, okay? So this is the first formula, this is the second formula using which we will be solving this particular problem, okay? So in this space, like 1 plus sine 2x, all right, can I not write this 1 as cos square x plus sine square x? Because cos square x plus sine square x is nothing but 1 only, plus sine 2x we will replace by 2 sine x cos x. So what formula are we getting? A square plus b square plus 2 ab or ba, whatever, 2ab or ba, all right? So which is nothing but a plus b whole square, right? What is our a here? Cos x. What is our b here? Sin x, which is whole square. A plus b whole square, right? Now just change this particular, this doesn't really change anything, just for convenience we write sine first and cos next, okay? Just for convenience I did the change. Now in order to solve this problem, all right, in order to be able to solve this problem, first our work will be to basically break it. So I have cos x minus sin x in the numerator, and in the denominator what do I have? I have sin x plus cos x whole square dx, okay? Like I can replace 1 plus sin 2x by sin x plus cos x whole square, all right? So in place of like now we will be considering sin x plus cos x as our t. So if I do that, what next? After taking the derivative, we will get cos x here, because the derivative of sin x is cos x, and the derivative of cos x is nothing but minus sin x into dx equal to dt. Now I hope you understood that why we did all these manipulations. So after getting a cos x minus sin x into dx equal to dt, so this entire numerator part will get replaced by a dt, right? And in the denominator, this part we took as t, so in the denominator we have a t square and dt, right? Now this can be written as t to the power minus 2 when t to the power 2 comes in the denominator into dt. And finally when we integrate, we get minus 2 plus 1 divided by minus 2 plus 1 plus c, which is nothing but t to the power minus 1 divided by minus 1, which is nothing, plus c, which is nothing but minus of 1 by t plus c. Now I have to replace this 1 by t as nothing but sin x plus cos x, write this minus here, plus c. All right, so the final answer is minus of 1 by sin x plus cos x plus c. So these were the 3 questions that I solved respectively, okay? I hope you got a hang of these kinds of problems now. We will solve a few more before getting into the next, okay? It is very important that you build a firm base in these kinds of problems, because you will be requiring direct applications of these when you will be solving other kinds of advanced problems for your competitive examinations, okay? It is very important for you to build this firm base, else you will keep on getting stuck, all right? This actually happened in case of me when I used to be a JEE aspirant. I used to fail in solving numericals from the JEE part, because I wasn't really very comfortable with integration, okay? This entire chapter requires a lot of practice, and only those who practice and revise regularly are able to master these concepts really well. Integration doesn't require a high level of, you know, intelligence or something. This is not, in fact maths itself is nothing like that, but this integration specifically I think is very confusing, because there are just infinite ways, infinite formulas, so it feels like you won't be able to get a hold of it. But trust me, once you just start solving different kinds of problems, you get a hang of it, then you can solve even the toughest of the problems. Okay, so if you really like my video, then please don't forget to like, share, subscribe, and hit the notification bell icon for more of such exciting content. See you in the next video.